Okay, so we're just doing more of the rules for exponents. So let's talk about what this really means. I'm going to expand it first. So this says, hey, you're going to take 3b squared and multiply it by itself 3 times. 3b squared times 3b squared times 3b squared. This says you're multiplying just this first parenthesis by 2b to the 7th. So what is 3 times 3 times 3? Times 2 is 54. Let's count our b's, exponents. I have 2, 4, 6, plus 7 is 13. Now let's use the rule that says take a power to a power. So this is what we should end up with, but I'm going to show you the power rule because that's really what's happening here. The power rule says 3b squared raised to the 3rd power. I take this power on the outside and I distribute it to the 2 powers on the inside. 1 times 3 is 3, so that becomes 3 to the power of 3 and b to the power of 6. Well, 3 to the power of 3 is 27, b to the 6th, times 2b to the 7th. I have to multiply the constants. 27 times 2 is 54. 6 plus 7 is 13. So you can use either method, right? You're going to get the same answer. You're going to get the same exact answer. You just need to decide which method is going to work best for your brain. So I'm going to expand it and use the power rule on each example that we do, just so you can kind of see what it looks like. So for number 31, the numerator doesn't change at all for this first step, 32x to the 8th, but the denominator is really negative 2x cubed times to the power of 3, right? So that means times negative 2x cubed times negative 2x cubed. That's what's going on there. So I'm going to keep the 32x to the 8th in the numerator. But the denominator, let's see, what is negative 2 times negative 2 times negative 2? Well, 2 times 2 times 2 is 8. A negative times a negative is a positive, times another negative is a negative. And the product rule says if the base is the same, you add the exponents. 3 plus 3 plus 3 is x to the 9th. Okay? Well, can we divide 32 and negative 8? We can. So that just becomes negative 4 upstairs with an x to the 8th power and an x to the 9th in the bottom. So we have to focus on fixing the variable terms. What does the quotient rule say? If the bases are the same and I'm dividing, I subtract. So I'm going to really rewrite this as, minus 9. And I'm going to get rid of it out of the denominator. So 8 minus 9 is what? Negative 1. So now I have negative 4x to the negative 1 power. What's being raised to the power of negative 1? Just the x. So it becomes negative 4 over x. I'm going to show you the other way using the power rule. So 32x to the 8th over negative 2 to the power of 3. And then x to the power of 3 times 3 is 9. So here's another thing that you can think about. When we first learned about exponents, if the number on the top is smaller than the number at the bottom, you're going to end up with an exponent, like a variable on the bottom, right? Because if you expand this x to the 8th is x times 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 x. X to the 9th is x times 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 x. Cancel them off. 1, 2, 3, 4, 5, 6, 7, 8. I have 1 left in the bottom. because there's one bigger in the bottom than there is in the top. Does that make sense? So you can just go without even subtracting it. Just know that you have 8 x's up here, 9 down here. When you cancel them out, you're going to have 1 left in the bottom, which is what we ended up with. Is that making sense? No? Okay. Did you guys ever learn how to expand your exponents when you learned about exponents? Okay, let me write it nice and slow. So let's go ahead and get rid of let's simplify the 2 to the third. Negative 2 to the third we know is negative 8. So this is just going to end up being a negative 4. But I have 8 x's up here. 1, 2, 3, 4, 5, 6, 7, 8. That's what x to the 8th looks like, right? Yes or no? So that's all just being multiplied together. We've already simplified this. Negative 32 divided by negative 8 is negative 4. X to the 9th is 9 x's. When you reduce this fraction, you can take the same multiple out of the top as the bottom, right? These are x multiples of x. So I can take an x from the top. I'm just reducing it. We're taking factors out. And an x from the bottom, an x from the top, 1 from the bottom. I'm going to keep doing that. And I notice that I have 1 x left in the bottom. And that's because this is because the number 9 is 1 more than the number 8. So there's going to be 1 more x in the bottom versus in the top. So when you simplify them, know that, we'll do another example. I want you to know that if you simplify those, you can go ahead and subtract, but really what I want you to realize is, oh, I'm going to cross those out. There's 1 more x in the bottom than there is in the top, and just leave it in the bottom. Let's try again. Remind me to fix attendance, okay? All right. So let's look at this one. If I use the power to a power, like raising a power to a power, this is negative 2 to the power of what? What's 1 times 2? 2. This is b to the 5 times 2 is 10. Times, what's 3 times 1? 3 to the 3rd power. And what's 4 times 3? 12. Okay. Negative 2 squared is, did someone say negative 4? Negative 2 times negative 2 is positive 4. A negative times a negative is a positive, right? So positive 4 times b to the 10th times, what's 3 cubed? 3 times 3 times 3 is 27 times b to the 12th. Well, 27 times 4 is 108. 10 plus 12 is 22. Do you want me to expand it? Are you okay with that? There's a cheat for exponents and negatives. So you guys should have learned this when you multiply negative numbers. And I just am saying shame on your teacher for not teaching you this. So can I just show you something really fast? Negative 7, negative 2, negative 1, 4, 5, negative 3. Okay. I don't even know the number there, but I know that my answer is going to be positive. How do I know that right now? Just looking at that. How do I know that my final answer is positive? Without putting it into a calculator, how do I know my final answer is positive? There's an even number of negatives. You know that a negative times a negative is a positive. So whenever you have an even number of negatives or a multiple of 2, right, then your answer is going to be positive. And that works the same with exponents. If you have an even exponent, that'll become positive. If you have a negative exponent, like up here, not a negative, sorry, an odd. See how we took this negative 2 to an odd power? 3 is an odd number. It ended up being a negative 8 when we simplify that. Okay? So that is something that you guys should have learned when you multiplied integers. And if you didn't, like I said, I feel like I should just beat down your teacher because that's super important. That saves you so much time when it comes to thinking about numbers, right? Count the number of negatives. If you have an even number of negatives, your final answer is positive. If you have an odd number, it's going to be negative. If your exponent is even, your answer is positive. If your exponent is odd, when you raise a negative number to a power, it will still be negative. Okay? Does that help a little bit? All right. This one is another expand, like this is another power to a power. So I'm going to put a 1 there because that helps me think about it. And I have to distribute this power. Notice that the whole fraction is not grouped. I have the numerator raised to the 4th power and the denominator is being raised to the 2nd power. So I'm going to put a 1 right here and I have to distribute this 2. So let's kind of simplify that. 3 to the 1 times 4 is 3 to the 4th power. X to the 4 times 4 is x to the 16th over -2 to the 2 power. So is my final answer going to be odd or even? I'm taking -2 and I'm raising it to an even number. So is my final answer going to be positive or negative? It's going to be positive. 2 times 2 is 4. -3 times -2 is x to the -6. So the first thing I'm going to do is figure out what 3 to the 4th is. I think it's 81. Here's how I do that quickly. What's 3 squared? 3 times 3 is 9. And 3 to the 4th is just 3 squared twice. 9 times 9 is 81. I'm not a math genius. I just kind of know tricks, right? So I have 81 over 4. That takes care of my constants. Talk to me about the exponents. This guy is in the denominator, in the bottom bunk, and he's sad. What do I need to do with him? Move him to the top bunk. So I just moved him to the top bunk. So what is 16 plus 6? It's 22. There's not going to be any x's downstairs at all. Where does 22 come from? 16 plus 6, right? Because do you see that? Ma'am. It's not negative. That's 81 over positive 4. That's an equal sign. Sorry. You could reduce 81 over 4, but it would be a decimal. So I wouldn't reduce it. Leave it as a fraction. Okay. All right. Let's look at some applications of exponent rules. So we're asked to find the area. So we know that the area of a rectangle is the length times the width, which means that I'm going to take 11x times 3x. I'm going to multiply the constants. 11 times 3 is 33. The powers, the bases are the same. So I'm going to add the exponents. And I'm just going to write square units because I don't know what the units are, but I'm going to make sure I label it. Yes or no? Okay. Let's talk about the area of a triangle. The base times the height divided by 2. So my base is 10p times my height, which is 4p, all over 2. So what is 10 times 4? 40. What is p times p? P squared, right? Because these are p to the first. Add them up. All over 2. Can I reduce that one more? Yeah. 40 divided by 2 is 20. So I end up with 20 p squared square units. Are we ready for the next one? What does question C say about that figure? It says it's a what? It's a square. All of the sides are the same, which means it could be a square or a rhombus, but it has right angles. So that means that it's a square. So what do we know about the sides of a square? They're equal. So if I want to find the area of a square, I just take the side measurement and I square it. So I'm going to take 1/2 W and I'm going to square it. So I'm going to change colors really fast. So that means that the 1/2 is raised to the power of 1 and the W is raised to the power of 1. And I'm going to distribute that power. So that really says 1/2 the quantity squared times W squared. Well, 1/2 squared is just 1/2 times 1/2 W squared. And what is 1/2 times 1/2? 1/4. Yeah. We multiply fractions straight across. 1 times 1 is 1. 2 times 2 is 4. So 1/4 W squared square units. Okay. Okay. Are we still writing that down? Or are we good? Okay. Oh, dang it. Okay. Number 35. A rectangle has a width of 5x to the 4th and a length of 5x cubed. So I'm going to draw a picture of my rectangle and I'm going to label it. My width is 5x to the 4th and my length is 5x cubed. Doesn't matter which side I label as length and width, first off. No, it doesn't. So it says write an expression for the area. Well, the area is the length, 5x cubed, times the width, 5x to the 4th. Can we simplify that? What does it become? I have to multiply the constants. 5 times 5 is 25. X to the 7th. Yeah, when we're multiplying, we add the exponents. If you forget that rule, write out what x to the 3rd power looks like. Write out what x to the 4th power looks like. Count how many x's you have. Okay. We're going to do some more applications. All right. A parallelogram has a base of 8z squared and a height of 4z to the 5th. So I'm going to draw a picture of a parallelogram. I'm going to put my height in here. So my base is 8z squared, and my height is 4z to the 5th. What is an expression for the area of the parallelogram? Well, remember that the area of a parallelogram is just base times height. So that means I'm going to take 8z squared times 4z to the 5th. So someone who hasn't gone, who wants to share what they think? 32. Who was that secret speaker? Was that you, McKinley? So 8 times 4 is 32, not 37. Sorry. Z to the, how did you get Z to the 7th? Good job. 2 plus 5 is 7. So 32 Z to the 7th square units. I don't think I put that on that last one. Okay. Ooh, this is a good one. So now we're finding the missing measure. So we have a triangle and we know what the area is. We know that the area is 18x cubed. Remember that the formula is area equals base times height divided by 2, okay? It says that the base is 4x. I don't know what the height is, so I'm going to use that variable h, but I still have to divide by 2, right? mean, all I did was take the A equals BH divided by 2, and I substituted in the area for this right here and the base. So what should I do first? Multiply both sides by 2. I have to get rid of that divide by 2. Multiply this side by 2 over 1. I'm going to multiply this side by 2. So 2 times 18 is 36. The x cubed just comes along for the ride. Equals, and these cancel out. So it equals 4x times h. Trying to get h all by itself. That's a multiply. What's the undo of multiply? Divide, yeah. Divide both sides by 4x. Divide both sides by 4x. So when I do that, I'm going to kind of move over this way. 36 divided by 4 is 9. X cubed divided by x to the first is, well, 3 minus 1 is, and that equals h. Let's do it again. It says the area of a rectangle. We know that the area of a rectangle is the length times the width. The area, which is 45, x to the 6, y to the 4th, and the length, which is 9xy cubed, and I have to figure out what the width is, times w. Well, what's the undo of multiply? Divide. So I have to divide this side by the 9xy cubed, because I'm trying to get w all by itself. And that means I have to divide this side by the 9xy cubed. So 45 divided by 9 is 5. X to the 6th divided by x to the first. Well, 6 minus 1 is x to the 5th. Y to the 4th minus y cubed, or 4 minus 3 is y to the first, or just y. I'm not going to write a 1 there. And that equals my width. Okay. I'm going to do a couple of the scientific notation. So remember what I said. If you're going from scientific notation to standard, that's what, like when we write numbers out regularly, like 2000, 20000, that's called standard form. So if you're going from scientific to standard, if you have a positive exponent, that means you move to the right. If you have a negative exponent, you move to the left. And that makes sense because 10 to the 4th power is 1, 2, 3, 4. It's 10,000. Saying take 3.23 times 10,000. Lorelai. Yeah, positive, you move to the right. So I'm taking this number and multiplying it by 10,000. So it's going to get bigger. I'm moving the decimal 4 times. 3, 2, 3, 0, 0. The decimal was here, and I moved it over 1, 2, 3, 4 places. Does that make sense? Do you need to see me moving it? 3.23. I move it 1. I don't know why that keeps doing that. 1, 2, 3, 4. So you have to put some zeros in there. Okay, so it equals 32,300. This has a negative exponent. That means I'm going to make this number smaller. How many times smaller? I'm moving the decimal 3 times to the left. So I have to put 2 zeros there before the decimal. So the decimal is 0. I have the decimal place 00509. And I always throw a decimal on the other side, a 0 on the other side, just to make it look nice. If you're going from standard form to scientific, you do it the opposite way. If you have a positive exponent, well, the positive exponent, I'm not even going to write that out. I think that's going to be confusing. Here's what I want you to think about. When I put this number in scientific notation, remember that scientific notation has a number outside of, like, to the left of the decimal. So this is going to become the number 5.93. 5.93. It can only have one number to the left of the decimal. So, and it's got to be between 1 and 10, right? So it's 5.93. So let's count and see how many times I moved that decimal. Well, the decimal is right here, and I moved it 1, 2, 3, 4, 5, 6 times. So times 10 to the 6th power. But I want to talk about that. With that positive exponent on the 10, I'm making this number bigger, right? Is the original number bigger than this, or is it smaller? So that means your exponent has to be negative. Let's look at number 42. The scientific number, the A, the constant out front, can only have one number to the left of the decimal. So I have to put a decimal right there. So that's going to be 6.305. Drop off all those zeros. Okay. Let's count how many times I moved the decimal. 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8th. Is the original number, the standard notation, the standard form, is it bigger than the scientific number or smaller? Bigger. That's why that exponent is positive. So I'm going to make this number bigger. So I'm going to take, for this last one, it's kind of a hodgepodge of numbers. It's not written in any form. So I'm going to take the number 130. I don't know why that's doing that. And I'm going to multiply it by 10 to the 2nd power. This tells me how many times to move the decimal. What am I doing? Moving it how many times? 2 to the right. So I really have the number 13,000. So we're going to take the number 13,000 and write it in scientific notation. Well, I know that my decimal has to end up here. That's 1.3. Let's see how many times we moved it. 1, 2, 3, 4 times 10 to the 4th. So I'm going to show you why that works like that. If I had originally put this number in scientific notation, 130, the decimal is right here. I would have to move it. So that's really 1.3 times 10 squared times 10 more squared. The base is the same. I add the exponents, which is why it's 10 to the 4th. Okay. When you evaluate powers, you deal with the constants first. Like when you evaluate standard, like stuff in scientific notation, you deal with the constants, and then you deal with the like base 10 numbers. So this just says, hey, take 3.1 and multiply it by 2. And then take 10 to the 6th power and multiply that by 10 to the 4th power, 10 to the negative 4th power. So 3.1 times 2 is 6.2. 10 to the 6th times 10 to the negative 4 becomes 10 to the 2nd. So someone tell me how to do number 46. How should we rewrite that? Let's change the order up a little bit. Yeah, 1.2 times 1.2. Perfect. So what is 1.2 times 1.2? Well, 12 times 12 is 144. So 1.2 times 1.2 is 1.44. Times, because I have to write it in scientific notation, 4 plus a negative 9? What is 4 plus a negative 9? So that becomes 10 to the negative 5 power. Okay. I'm going to do number 45, and you guys can do 47. So I'm going to divide those two numbers. Someone with their calculator, take 5.1 divided by 1.5. 3.4. So when I divide these, I get 3.4. What does the rule say to do here? Subtract. So that becomes 10 to the negative 5 minus negative 3, right? Because I'm subtracting negative 3. What happens when I subtract a negative? Turns into a positive. What does negative 5 and a positive 3 become? So it really becomes 3.4 times 10 to the negative 2. So you guys do this one for me. Someone share. What is 1.21 divided by 1.1? Yeah, it's 1.1 because that's 11 times 11, right? What is 10 to the negative 8 minus a negative 2? Yeah, because this becomes positive. So my answer is 1.1 times 10 to the negative 6. Okay. All right. So turn to page 8. I'm just going to do 2 of these. I'm going to pick 2 out of each category just to make sure you guys understand the rule. So I'm going to do number 1. Tell me what anything to a negative power tells me to do. Bunk bed story. Move it downstairs. Right? Tell me anything to the 0 power is what? 1. So 3d squared all to the 0 power is 1. If the base is the same and I'm multiplying, product means multiply. If the base is the same and I'm multiplying, what do I do to the exponents? That becomes 7 plus 12, which is 19. Do you want me to do number 7 or number 8 as well? 8. Okay. This negative is like a negative 1. 9 times negative 1 is negative 9. If the base is the same, I add the exponents. 10 plus 5. If the base is the same, I add the exponents. Y to the 3 plus 3. So it actually equals negative 9, x to the 15th, y to the 6th. That's the product rule. We just call it product rule, okay? The quotient rule. If the base is the same, I subtract the exponents. So I'll do number 10. So I have to divide the constants. 6 divided by 3 is 2. The bases are the same here. So that becomes c to the 3 minus negative 5. If you're struggling wrapping your brain around that, I'm going to finish it out really fast. That becomes c to the 8th. But if you're struggling wrapping your brain around that, do this. Do you see how this is unhappy downstairs? Move it upstairs. My pen's dying. So that says c to the 3rd times c to the 5th, which tells you that you're going to have a c to the 8th in the top. Okay? If you can't do minus a negative, if that's tripping you up, do that. Let's do number 9. 9 divided by -1 is -9. 10 minus 5 is 5. 3 minus 3 is 0, and anything to the 0 power is 1. So that's it. That's your quotient rule. Ma'am. Yeah, sure. What is 2 and -4? How can I simplify that? Nothing up here, and what's this become? What? Just looking at the constants. The 2 goes away, and it becomes a 1, and what goes in the bottom? We're reducing -2/4. It becomes -1/2, right? Yes or no? Is there more D's in the top or in the bottom? In the bottom. How many more in the bottom? 2. Just keep it down there. You could do D to the 7th minus 9, but you're going to end up with D to the -2 upstairs, and you'd have to drop it down anyway. Do you see what I'm saying? That this bottom has 2 more than the top, so you're going to have 2 left over? That is not making sense to you. Okay. I just want you to look at the exponent D, this power right here. You're going to subtract those, right? But when you subtract, you get rid of the fraction. When you're using the quotient rule, it says, hey, we're not going to use it as a fraction anymore. We're going to use it as a product rule, but instead of adding, we're going to subtract. Okay? 7 minus 9 is -2. So this becomes D to the -2 up top. And then the D to the 5 stays down in the bottom. That's what really is happening when you use the quotient rule. Okay? But I can't have a -2 upstairs, so I need to drop it downstairs. And then I'm going to add these two. And 5 and 2 is, so I really have 1 over 2D to the 7th. And I always move the negative out to the side. Because it doesn't matter if your negative is in the numerator, the denominator, or out to the side, as long as we're not raising something to a power. Here's another way you can do that. This is why I think exponents are so cool, because you can do it a million different ways. You could add these together first. So you could have 2D to the 7th over -4D to the 14th. Do you have more D's in the numerator or in the denominator? That means that when you simplify it, you're going to end up with all your D's in the denominator. Because remember, imagine stretching out 7 D's in the top and 14 D's in the bottom. So when I simplify it, the D's stay in the bottom. Does that make sense? So that's why I have 14 minus 7 is 7. That's why there are 7 D's in the bottom.
What was the 1 over -2d10? The one at the back.
What is this one right here? I subtracted these two. I just focused on 7 minus 9 is -2. I didn't simplify the bottom yet. Okay. All right. This is a power to a power. When you have a power to a power, you multiply exponents. If you can't remember that rule, think about what this says. This says take this and multiply it by itself 4 times. Well, the product rule says that you add all of these. 3 plus 3 plus 3 plus 3 is 12, which is what 3 times 4 is. Okay. So we're going to use the product or the power to a power rule here. 3 times -1, well, that's -3. Can we leave our answer with a negative exponent? No, it's mathematically incorrect. It's not acceptable. So I have to drop this down. So I'm going to put a 1 over the top of it and make it C, 1 over C to the positive 3. Number 15, what does that become? D to the -10, which I can't leave it like that. So then I change it to what? 1 over D to the positive 10. Let's look at number 16. So, ma'am. Yes. So this first parenthesis is not being raised to an exponent on the outside, but the second parenthesis is. So let's take care of this power to a power here. So I have 6x cubed y times, what is 2 times negative 2? What is 2 times negative 2? X to the negative 4. Okay. Is x happy where it is? No, this one's not happy. So you can make a decision right here. You can say, I don't understand negative exponents and they're really tripping me up. And you can move that down. So I'm going to do that below, or you can simplify it off to the right. So I could rewrite this as 6x cubed y over a positive x to the 4th. And I've gotten rid of that negative exponent. Okay. Do you have more x's in the numerator or in the denominator? In the denominator. How many more x's do you have in the denominator? 1. So that's what I would leave down there. 6y over x. Now, if that doesn't sit with your brain, you could do this. You could use the product rule that says, hey, those bases are the same, add them together. So that becomes 6 times, well, 3 and negative 4 is negative 1 times y. And then you can say, oh my gosh, this guy is in the numerator. He's not happy. I need to drop him downstairs. And I'm not even going to write that power of 1, right? Because once you move him downstairs, it's a positive exponent, so you don't even need to raise it to the first power. So you'll get the same way. You just need to choose what method kind of situates the best with your brain. Okay? All right. So I want to talk to you about your homework. So I'm going to go back to page 6. So pay attention because I'm going to circle them on here, and I'm not making you do every problem. I think that's totally asinine. So I'm going to have you do is it okay that I said asinine? I'm sorry. Sorry, it is asinine. Okay, we're not going to do all these problems. Number 4, number 6, number 7, and number 8. Okay. Ava, will you do me a favor? Will you circle them on my notes too as well, so I know which ones I need to do? And I'll adjust Canvas in a second. Let's see. We have number 10 and number 11. And I'll do the rectangular prism. I will do this one just so you can see it, but you guys don't have to do number 12. So here's do 10, 11, and 12. That's it. 10, 11, and 12 on that page, okay? But I'm going to do number 13 because I want you to see it. All right? Thank you. Okay, let's keep going. So we kind of went through this. I want you to choose one from the power of a product. Choose one. I don't care which one. I want you to choose. So 17, 18, 19, or 20. Choose one to do. 21, 22, 23, 24. Choose one. Does that make sense? You pick. I'll do them all. You just pick one. Am I making sense? You're confused. What's going on? You're looking at me like you don't understand. You pick. I have to do all of them. You choose one to do. I will do them all. You pick one. Like you just pick one. Look at them and decide which one you want to do. I'll do them all because I think it's good for you to see them. Okay? Choose one. On number 25 through 28, I want you to choose 2. Choose 2. And then here, choose 1. My pen is dying. Sorry. Choose 1. I need to change the batteries. So you pick any one you want. I'll do them all. Okay? Are we good? Okay, I'm going to go to this last page. So let's do Let's do 3 and 5. So it's got some negatives. 12. 13, because it has a fraction in it. 18. Hey, you should be thankful that you're not upstairs. They have to do all of it. They have 57 problems to do. 6. I'll sign 11 because it's super easy. And that's it. Okay. So I'm going to go through and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. You have 19 questions. That's not too much. Yes. 19 questions. Choose one, choose one, choose two, choose one. Yes. Hey, wait till she gets back. Okay, so I need to update. Oh, wait. Yes. Six, seven, eight.
My mom says that she's in the office, but they won't pull down here. Can I go down
Class is over in like 10 minutes. Can't you just wait? They'll write you a pass to your next class. I'll let you leave like 3 minutes before the bell rings. There are no bells today. You have to wait till Rosie gets back, and then Taylor is going. Who are you frightened of? Who's intimidating you? You're afraid of her driving, or just her in general? I can understand that. I'm afraid of my daughter's driving, so I mean, I get that. So how am I going to write? Like, so for page, here's what I'm going to write. I'm going to choose. I'm trying to write directions for people who aren't here. So first, don't let me forget to adjust attendance. Section 1, choose 1. All right, who circled the problems on page 10? I did, but I'm not writing that. Someone rattle them off for me. What are they? Staley's got them. Sorry. Go ahead.
3, 5.
Got it. Thank you, ma'am. Yes. Let me update that. I just have to hit save. So you're not here today. Imagine looking at this. Do you think that that makes sense? No? Okay. I'm going to put a comma after the 18 and add bottom section. But how do you find the volume of a shape? Not length times width. Volume. Volume is three-dimensional. So you have a length, a width, and LWH. Okay. Right, because it tells you that you're supposed to. You have the height. You don't have the. You don't have the length. So label this W. Label that H. So volume. I think that's right here. So this number right here equals this times this times this. I put my L here. Yes. So you're gonna multiply all those together. I'm gonna step on the five. Yeah, I'll multiply itself. 5. That's probably for you.
Like stop.
Oh. She is on her way. Bye-bye. Miss Cindy, look at that. Go.
Okay.
Go. Yes, it is. That's gonna be a long video, isn't it? Oh yeah, that's really good.